All right, so in the tracker software, what you're going to do is you first need to load a video. So I'm going to click on this button here to load our video. Now I have to find it. It's going to be a little different on your computer than on mine because I'm on my Mac, but you're going to go to your downloads folder, wherever that happens to be. And as I said, it'll look a little different on yours than on mine. But I'm going to go to my downloads folder. I'm going to sort by date so I can find the file I'm looking for, and here's my video. Now, this video is the kind of the perfect video. What you're going to need is you want your camera to be 100% stationary. You're also going to see when I play this, you'll see that the ball rolls from left to right across the screen. So the ball is moving parallel to the iPad screen in this case. So it's recorded on an iPad, and you can see that the motion is perfectly parallel to the camera. That's what we want. And then you can see our entire scale bar right here. So this is the perfect video for video analysis. First thing we need to do is create a scale. So we're going to come up to this button, and we're going to say New Calibration Stick. And you'll see right here this blue thing appeared, and if I grab the end of it, I can drag this to each end. And this is a meter stick, so you can see right now it says it's 1 meter. And again, you want it as close as you can get it to both ends of that meter stick. And then if this was not a meter, if it was only 10 centimeters, you'd just have to change your scale. You can come up here and you can make this 0.1 meters if it was only 10 centimeters. But this tells the video how big your video is. All right, we're going to drag our slider here back so we can get our ball back on the screen. And where are we at? There we go. And we can use these buttons down here to toggle frame by frame. And really you want to start with the ball on the table. So I'm going to start here. To track the motion, what we're going to do is we're going to click on the track button. And we're going to say New. And you're going to click Point Mass. And now you'll notice some cool stuff happened over here. We got a couple of graphs have appeared. We have a graph for the X position and a graph for the Y position. And we have a data table. Nothing is on that though. We need to start adding that. So what we're going to do is if you hold the Shift key down, once you're in, make sure that you've clicked on the video. You're going to hold the Shift key down and see how my cursor changes. When I hold the Shift key down, I'm holding the Shift key down, I let go. You see how my cursor changed. I'm going to put the cursor right at the front edge of the ball, and I'm going to click once. And you'll notice there's now a point on my screen and a point on my graph. And the video advanced 1 frame automatically. So I'm going to hold Shift down again, and I'm going to click the front center of my ball. And I'm going to do it again. I'm going to keep clicking the front center of my ball. And you can see my ball is actually bouncing a little bit. That's fine. It's not that big a deal. I'm just going to, now it stopped bouncing. So I'm just going to keep clicking that front edge of the ball. And you can see my data table is populating, and you can see my X and Y position time graphs are forming. So I'm going to go ahead and keep clicking that. It doesn't have to be the front edge of the ball, but it should be the exact same point on the ball on every frame. I like the front edge because it's less ambiguous. Now, you'll see my X position is always increasing, and you can see my Y position is all over the place. But you'll also notice it doesn't vary a whole lot. 0.36 to 0.37, that's a centimeter. So that's okay. We're not worried about that one anyway. We're really worried about the motion in the X direction right now. The other thing we can do, you can see that my X starts at like negative 0.4 meters or something. If I click this one, you don't have to do this piece, but you can if you want. If I click this, I now have an origin. So this is where the origin is, the 0 point. I could actually put this over here at the base of my map. You see how my numbers are changing on my graph? So now all of my X is in the positive range. You'll notice my time range though starts at like 3.2 seconds. Again, you can adjust that, but I'm not going to worry about that for now. So once you're at this point, you've got your origin on there, you've got your scale bar on there, and you've dotted the motion. We're going to right click on our graph. We're going to right click on our graph, and we're going to come down to where it says Analyze. Now, you'll notice right now all of the points are highlighted. If you only wanted a portion of the graph, you could click and drag around just a portion of the data. But if you don't click any of it, it'll just assume you want to analyze all of it. I always like to do a portion of the data. That way I know exactly what I'm getting. So, but once you've done that, if I click the Analyze button, I then want to do a curve fit. Now, there are different sorts of equations I could try to fit to this. This is clearly a line though, so I'm going to use the line as my fit. Many times it's going to be a parabola. So a lot of times in physics it'll be a parabolic, but there are different sorts of graphs you can fit to this. I'm going to fit a line. Now, what am I looking at? Here is the equation it's using where it says x equals a times t plus b. You may recognize this as the format of the slope-intercept form of a line. But why is x over here on the left-hand side? Because x is on my y-axis on this graph, while t is on my x-axis on this graph. So x will vary with the slope of the line times time plus the y-intercept. And over here you can see the slope of my line is 1.682 E0. What's E0 mean? E0 means times 10 to the. Okay, so it's always going to be a 1 point something, but you want to make sure that if that said times E1, then that would be 1.68 times 10 to the first, which would be 16, all right? So it's always going to be in this scientific notation. So in this case, our slope is 1.68. 1.68 what though? What are my units? Well, if this is slope, x is measured in meters and time is measured in seconds, my slope would be 1.68 meters per second. And as it turns out, if I'm moving at a constant speed, that's my speed. The slope of my the slope of my position time graph will be my speed. So that's how you're going to use Tracker for this assignment. Then once you're done with that, I would create a new file, import the new video, and then do the same thing.